Hello, this is Mrs. Ward, and I am going to go over the notes for section 5.5, the multiple angle and half angle formulas. So this is going back to trig as we promised, and when we go back to trig, just a reminder, I'm giving you a blank unit circle. You probably want to fill that out. If you somehow forgot those values, you're going to have to go back and relearn them, rememorize them, do whatever. But in this class, you're going to be responsible for example, knowing that this is 30 degrees, pi over 6, and the ordered pair that represents that is the square root of 3 over 2, 1/2. You need to know that for all the values of the unit circle because some of these questions you are going to be asked to evaluate at different trig functions. And just to remind you, why do we need these multiple angle formulas and half angle formulas? Well, it should make sense to you that if I'm here at 90 degrees, and I know that that ordered pair is 0, 1, so the cosine is 0, the sine is 1, so pi over 2. It should make sense to you that if I want to find half that angle, so 45 degrees, I can't just take this cosine, which is 0, and cut it in half and get 0 for every single, and make this 0. That doesn't make sense because we should know at 45 degrees, or pi over 4, this sort of pairs the square root of 2 over 2. So I can't just multiply the angles or double the angles, the values of the angles. I have to actually use these formulas. So we are going to do the half angle formulas, the double angle formulas, and we are going to rewrite and solve real life problems. So let's look at these. Example number 1 is asking us to solve an equation. And remember, there's two types of solutions. One is for all solutions, and one is in an interval from 0 to 2 pi. This one doesn't tell me which one it wants, so we're going to assume it wants all solutions. Here are my double angle formulas. To solve this, I have to rewrite it in one trig function. So I'm going to go over here, and I have 3 formulas for cosine 2x. I have 3 of these formulas, and I can choose which one will best help me in this situation. Well, when I look at the equation, the other trig function I have is this cosine x. So when I'm choosing which one of these 3 to use, I'm probably going to use the one that only has cosine in it. So that way I would put everything in terms of one trig function. So what I'm going to do is I'm going to rewrite this cosine 2x as 2 cosine squared minus 1. So this will be 2 cosine squared x minus 1 plus that cosine x. So that I'm not rewriting is equal to 0. Now I'm probably going to product sum, so I'm going to rewrite this in descending order of exponents. And when I do that, just a refresher, my product is in -2, my sum is a +1, so I'm going to use 2 and -1. So I'm going to have 2 cosine x plus cosine squared x, sorry, plus 2 cosine x minus 1 cosine x minus 1 is equal to 0. All I've done to remind you is that I've rewritten this cosine x as 2 cosine x minus cosine x. And I got that from this table right here. Now I'm going to look at the first 2 terms and factor out what I can factor out. So here I can factor out a 2 and a cosine x. And when I do that, I'm left with cosine x plus 1. For these 2, I'm probably going to factor out a -1 and have cosine x plus 1 is equal to 0. If I'm having a good day, these 2 will match, so I'm going to factor those out. And I'm going to be left with 2 cosine x minus 1 is equal to 0. Since I have 2 things multiplied by each other to equal 0, I'm going to use the 0 product property and set both of them equal to 0. And then I'm going to solve. So here I'm going to subtract 1 from both sides and get cosine x is equal to -1. Here I'm going to add 1 to both sides and get 2 cosine x is equal to 1. Divide by 2 and I get cosine of x is equal to 1/2. Then I ask myself, when is the cosine equal to -1? This is when I need to know my unit circle, and that's going to happen at pi. And then I ask myself, when is the cosine equal to 1/2, or when is the x value equal to 1/2? positive 1/2 and only positive 1/2, it's going to happen at pi over 3 and 5 pi over 3. So these are my solutions. And then depending on the verbiage, I would just write those as my answer. If it asks for all solutions, then I would add, remember that 2n pi where you add multiples of pi, or another lap around the unit circle. So that's example 1. Example 2 says use a double angle formula. So here are my double angle formulas again to rewrite this. So I see that I want to rewrite it so that it looks like one of these sides here. And the only one that's going to stand a chance to look like that is the ones where I have like subtraction in it. And the only ones where I have subtraction in it are these 3. So I noticed that these have 1s. So I'm going to factor out what I can. So I can factor out 3 and make it 3 times the point of 1 minus 2 sine squared x. So here's that 3. And then this 1 minus 2 sine squared x is right here. And that's equal to cosine 2x. So I'm going to say cosine 2x. Now these formulas all u, but this formula gave me an x, so I'm going to use the x and not the u. And that is my final answer. And that's all they want me to do, so don't overthink that one. The next one, given that the sine of u is equal to 3/5 and u is between 0 and pi over 2. So what that's telling me is draw a triangle in the first quadrant, because that's 0 and this is pi over 2, such that the sine of this angle, so I'll call this u, is 3/5. Remember that the sine is the opposite over the hypotenuse. Now I'm eventually going to need the cosine, so in order to do this, I'm going to say 3 squared plus x squared is equal to 5 squared. And so I get x squared is equal to 16. X is equal to plus or minus 4. Well, since this triangle is drawn in the first quadrant, this is a positive direction for x, so I'm going to have 4. So just to remind you, here I know that my sine of u is equal to 3/5, and now my cosine of u is equal to 4/5. Now it wants me to find the sine of 2u. So the sine of 2u, I'm going to follow this formula here. So the sine of 2u is equal to 2 times the sine of u times the cosine of u. So I'm going to do 2. The sine of u is 3/5. The cosine is 4/5. And I'm probably just going to do that on my calculator and end up with 24/25. Now for the cosine of 2u, I can choose whichever formula I want. Let's just go ahead and use the first one. So I'm going to say the cosine of 2u is equal to cosine squared, so 4/5 squared minus sine squared, which is 3/5 squared. So I'm going to have 16/25 minus 9/25. And my final answer is going to be 7/25. Now I know to find the tangent, I'm going to switch colors. To find the tangent, we'll do it this way. I'm going to use the formula the first time and then show you the trick. So the formula would be this formula right here. So I'm going to have to take the tangent. Well, I didn't write it down here, but the tangent is the opposite, which would be 3 over the adjacent, which is 4. So for the tangent of 2u, I'm going to take 2 times the tangent of u, so 2 times 3/4. And I'm going to divide that by 1 minus my tangent squared. So when I do all that, I'm going to have, when I multiply this, I'm going to have 3/2 over 1 minus 9/16. So I'm going to have 3/2 over 7/16. Keep, flip, switch, whatever you guys say. And when I do this, that is not right. Pause, please. found my mistake. When I simplified this, this should be 8. Because 2 goes into 2 once, 2 goes into 68. When I do that, I'm going to end up with 24 sevenths. And that's going to be my tangent to you. But let's be completely honest. If I already had the sine and I already had the cosine, so here I have the sine as 24 25ths. Here I have the cosine as 7 25ths. Easier way to find the tangent of 2u would be to take take the sine of 2u and divide it by the cosine of 2u. So I'm going to take the sine, which was 24 25ths, divided by the cosine, which is 7 25ths, and then when I would still end up with 24 sevenths. I think this is a much better way of doing it than using that formula, especially if you have to go ahead and find the sine and cosine anyhow. I did also want to bring up that if I only had this, and I didn't make my triangle or anything like that, and I just wanted the cosine of 2u, then I'm probably going to use this formula here where I didn't have to go find the cosine. But I had to find the cosine, so I used the first formula. All right, the next one, find the exact value of cosine 105. When it says exact value, what that says to you is you're not going to give me a decimal, you're not going to pick up your calculator, you're going to do it based on the unit circle. But the problem is 105 degrees is not on the unit circle. So it's asking me to use a half angle formula, which this is going to sound counterintuitive, but what I'm going to do is I'm going to take this 105 and I'm going to multiply it by 2. I'm going to get 210. So to get 105 degrees, I'm going to think of that as 210 degrees over 2, which makes it so that I can substitute into this half angle formula. This one just wants me to do the cosine, so I'm going to go ahead and do the cosine. So I'm going to say the cosine of 210 over 2 is going to equal plus or minus the square root of 1 plus the cosine, and I'm going to just write cosine of 210 right now, all over 2. So let's talk about a couple things. First of all, it's asking me to choose whether my answer is going to be positive or negative. 105 degrees is in, and hopefully you know this, is in the second quadrant. So it's in the second quadrant, so I know this angle's over here somewhere in the second quadrant. I am lying to you. No, I'm not lying to you. I thought I was lying to you. So that's 105 degrees. That is in the second quadrant. If I'm doing the cosine, remember all students take calc? Hopefully you learned that. Well, anyways, the only thing that's positive in the second quadrant is the sine and its reciprocal, cosecant, which means that the cosine has to be negative. So I'm going to choose the negative symbol for this one, because I am finding, to do this, I'm actually finding the cosine of 105 degrees. I know 210 is in the third quadrant, and that's also, the cosine is also negative, but I'm choosing this negative sign based on the 105. Okay, so let's keep on going. So I'm going to say 1 plus, now the cosine of 210 is going to be a negative square root of 3 over 2, and this is all over 2. Now, I got that because I know my unit circle, and hopefully you know your unit circle too. All right, I am going to simplify this using mental math. We love mental math. So I am going to think of this one as 2 over 2. So when I do, and I did that so that I would have a common denominator. This is negative, got my negative sign, negative. So I'm going to have 2 minus the square root of 3, all of my common denominator of 2, and then this whole thing is being divided by 2. So when I think of that whole thing being divided by 2, I think of that as being 2 over 1, which means I can multiply by the reciprocal. And when I do that, it's still a negative sign here. This is the square root of 2 minus the square root of 3. I'm going to multiply 2 times 2, I get 4. Now, at some point, you should learn that when you do a square root, you can do the square root of the numerator and the square root of the denominator. So when I do that, it's still a negative sign. This is going to be the square root of 2 minus the square root of 3. And this is all over, and the square root of 4 is 2. And that is the exact answer that I want. Now, it doesn't ask for it, but I just want to point something out. If it asked me to find the sine of 105, and I'm going to go ahead and do that. If it asks for the sine of 105, it's still basically the same work. I'm just going to think of it as the sine of 210 degrees over 2. When I use the formula, notice I'm still using cosine. You never use sine in this formula. And I'm going to do plus or minus the square root of 1 plus the cosine. So this will be 1 plus the cosine of 210, which will be 1 plus the square root of 3 over 2. And this is all over 2. Sine of 105, again, sine is positive in that second quadrant, so I am going to choose the positive sign here. So I'm going to make this positive. And it's going to be the exact same work as all this. I'm going to get the same thing, except for this minus sign is going to be changed to a plus sign. So I'm going to have the square root of 2 plus the square root of 3 all over 2. And make sure you make a point to show me that you know that this 2 is not underneath the radical sign. And again, if I wanted the tangent of this, I'm simply going to take the cosine, I take the sine, which is a positive square root of 2 plus the square root of 3 all over 2, and divide it by the sine, which is the negative square root of 2 minus the square root of 3 all over 2. It's going to be negative because I have a positive divided by a negative. These two will simplify, and I'm going to end up with the square root of 2 plus the square root of 3 all over the square root of 2 minus the square root of 3. Which looks kind of nasty, but that's the answer, and that's the tangent of 105. I hope that helps. Moving on. All right, so ignoring air resistance, the range of a projectile fired at an angle theta with the horizontal with an initial velocity is given by the formula of r is equal to 1/16 the initial velocity squared sine cosine, where r is the horizontal distance in feet that the projectile will travel. A place kicker for a football team can kick the football from ground level with initial velocity of 78 feet per second. So the first thing I'm going to do is I'm going to put this 78 in here. So I'm going to say r is equal to 1/16 times 78 squared, and then I'm going to have sine theta cosine theta. At what, so that's, I need to read the rest of the question. At what angle must the player kick the football so that it travels 180 feet? So this will be my R, my range, is going to be 188 feet. So when I put this in, I'm going to have 188, 1/16, and then 78 squared is 6084, and the sine of theta cosine of theta. And then I'm going to divide that by 16, or multiply by 1/16. And we have 188 is equal to 1521 over 4. This is still sine theta, cosine theta. And then I am going to multiply by the reciprocal. I guess is the best way to think of it. So I'm going to multiply this side by 4 over 1521. I'm going to multiply this 188 by 4 over 1521. So when I do that, I get 752 over 1521. That does not look right. Pause, please. That's right. Why do I doubt myself? Now this is equal to sine theta, cosine theta. The problem is, in order to solve for theta, I need to have it written in one trig identity. So what I hopefully you notice, if I go all the way back here to my formulas, I see that if I have sine times cosine, and I can put a 2 in front of it, that's equal to my double angle. Does that make sense? So when I go here, let's go all the way back down here. in order to make, so I know that sine 2 theta, or 2u, is equal to 2 sine theta cosine theta. So I need to make this side look like that. So I have this right now, and I need to put a 2 here so that it looks exactly like that. If I put a 2 here, I have to put a 2 here. So when I do that, I'm going to multiply this by 2. And when I do that, that's just going to double it. And I get 1504 over 1521 is equal to 2 sine theta cosine theta. And the reason why I did that is because now I want to rewrite this, which has 2 trig functions, like this, so then I'm down to 1 trig function. So when I do that, I'm going to say that this 1504 over 1521 is equal to the sine of 2 theta. Now I need to find the angle. I'm looking for an angle. So in order to find the angle, I have to do the inverse sine. So on this side, it's like I'm doing the inverse sine, because then these two will cancel each other out. If I do the inverse sine of that side, I have to do the inverse sine of this side. So I'm taking the inverse sine, and you should know how to do that on your calculator. And I'm putting it as decimal, and I get 1.42115 is equal to, remember, these two canceled each other out, so I'm left with 2 theta. So to find 1 theta, I'm going to have to divide this by 2, and I'm going to get 0.710573. I divided both sides by 2, and that's what my theta is. Well, that's great, but that's an angle, but that is an angle that is in radians. I know this is bringing back all the trig. So to change a angle in radians to degrees, remember you take that angle and you multiply by 180 degrees over pi. So I'm going to go ahead and do that. And when I do that, I get an answer of 40.71. So the kicker is going to have to kick it at an angle of 40.71 degrees in order for that football to go 188 feet. All right, I hope this helps, and I will see you next time in class.